Hi, this is Adam from MakerState. I'm here with the 6th webinar for the Maker Partnership Program. In this webinar, we're going to cover Applecatcher, which is Scratch Basics number 3. To deliver Applecatcher, you're going to need the same materials that you need for all of your Scratch challenges. That includes charged computers with internet access. Optionally, you can use your pre-printed Scratch blocks to introduce some of the concepts that your students are going to program, and then your printed rubrics and parent reports, and finally your design cycle poster. And your rubric and parent report can be found right here in the STEM Collab page for this challenge, right here under links to challenge materials, as well as a link to my Scratch prototype and the written lesson plan, which is kind of the written version of this video, as well as the engineering design cycle sections. Okay? So in the discover phase for this project, we're going to focus mainly on variables. This project introduces variables, and variables are a really important part of computer science. We use variables to store numbers and store other types of information like letters or words. And we can store these numbers, we can change them, we can use them for calculations, and do many other sorts of things with them. And in Scratch, in this project, we're going to use variables. We're going to use variables to store the score for our player. Okay? So our keywords for this project are variable, which, this works similarly also to how it does in a math context, right? Where we have a variable and we have a number, and then we're assigning a name to that number like X or something else. This is the same concept. We'll have a variable which is just kind of a placeholder for a number that can be changed or set, and we'll just call that number, in this case, score. And we'll see that in action in the Scratch project in a few minutes. The other keyword is random number generator, and that's a type of computer function that returns to us a random number that picks random numbers for us, essentially. And we're going to use that to create some unpredictable behavior for our game, which is fun because when you're playing a game, you want the computer to behave in a way that you can't always expect. And that creates, a challenge for the player. And so we're going to see that in this game as well. Okay? So in your circle meeting, here's some questions that you can introduce to your students. You can do these as think, pair, share questions or opening questions for the group discussion. What information does a computer store, and why is it helpful for computer programs to store information? So have your students think about that and think about the different sorts of things that when they're using an app or playing a game that the app needs to store in order to operate, or the game needs to store in order to make the game function, right? And after that, you're going to want to show how to create and use variables in Scratch projects, and we'll go over to Scratch and check that out in just a second, as well as introducing the new Scratch blocks for this project, which are pick random, or greater than, or repeat until. And repeat until, I should say. Okay, now we're going to go over to Scratch, and this is my Scratch prototype for this project, which you can get to by clicking on this link here. Scratch project prototype in the STEM Collab. And here we see that I've already created this variable. And for more specifics on how to create these variables and a more step-by-step walkthrough, you should check out the video in the STEM Collab of me building this project. But again, to create a variable, you just click make a variable, you type your name. For our projects, we're just going to use variables for all sprites, and we don't need them to be clad variables, so just these settings. You would type your name here, and then click OK. And then once you create a variable, you have all these options that appear for that variable, including set, change, show, and hide. These show and hide refer to the variable here on the stage, just displaying it. If I don't want a variable to be displayed, I can use hide variable, or if I want it displayed, I'm going to use show variable. And I do want it displayed because I want to display the score in this game. For more detailed walkthrough on how to create this project, check out that video in the STEM Collab on the main page for this lesson. But some of the key things happening in this project are this repeat until loop with this OR block. This is kind of a line with a lot of things going on in it. Repeat until touching bowl or Y position is less than -180. So what this line is doing is telling the apple how long to fall. And in English, we want this apple to fall until it either is caught by the bowl or hits the bottom of the stage, okay? And we can express that with the combination of these two conditions, which we can combine using this OR statement. So this apple is going to repeat falling until it's touching the bowl, or its y position is less than negative 180. Okay? And then we just have the changing y by negative 7 inside there to keep that apple moving down for as long as that happens. Then we decide whether or not we're touching the bowl or we've hit the ground by using an if-then-else block to, if we're touching the bowl, we'll play the sound pop and change our score by 1. Or if the apple falls to the ground, then it plays a different sound called chomp and sets the score back to 0. And let's just look at this in action quickly. Okay, so after your students build that project, they'll be in the improve phase, and here are just some playtesting questions to guide you through the playtesting process. Can the player move back and forth across the screen using the arrow keys with the bowl? Does the apple repeatedly fall from the top of the screen and then reset to a random position on the top of the screen? Oh, so let me just cover that quickly. We're using that random number generator right here in this pick random block, in this go to XY at the top of this forever loop, to reassign this apple to a random position along the x-axis in between every repeat. And so, if we didn't use a random number generator and we just had, a normal number here like 100, for example, then the apple would always reset to this same place right here, and this would be a pretty boring game. But by using a random number generator, we can have the apple go to a random place every time, and then I have to guess where it's going to fall. So that's how we use a random number generator to create unpredictability in our projects. Okay, so anyway, we just covered this question. This question now, does the game keep score? So are we using that variable to keep score? Was there sound added to the game? And then did the engineer do anything to go above and beyond the challenge and customize their project? Or are there any bugs or unexpected behaviors in the project that need to be addressed? Some extra challenges, you can add multiple objects that fall, so add different falling objects that are worth different point amounts, adding high score, by using another variable to keep track of the highest score reached in a particular session of the game, because the score resets, but maybe you could have another variable next to score here that was high score, that kept your high score, that didn't reset every time the apple hit the ground. Or you could find a way to make the game get more difficult as the score increases. And I'm actually going to show you how to do that right now, because that, I think, is a fun one. And it's fun because it shows us more ways that we can use our variable score. Okay, so right now we have this apple falling such that it falls at the same speed no matter what. And this is pretty easy right now. It's falling at -7. And I can pretty much always catch it at this point, unless I really get unlucky with how it's placed. But what would be better is if this game got harder as I kept playing it. And a way to do that is using the score block and using a minus block. And what I want to do is make this value here inside this change y block get further away from 0, a larger negative number, I should say. So maybe -10, then -12, etc., as my score goes up. And the way I can do this is by subtracting score from the starting value. And we need to start with something, because if we start with 0 minus score, then my score is 0 at the start of the game, and this apple will never move. So instead, we should start it with maybe -1, and that's really slow, so maybe we should start it with more like -5. And now, watch as I catch this apple, or these apples I should say, they will start to speed up and very quickly become harder to catch. So now, by the time I've caught 7 or 8 of them, they're falling really fast and I really have to react quickly, and at some point it becomes pretty much impossible to keep catching all of them. So there's a really simple way to add some responsive difficulty to our game here. Okay? After your students take a chance to improve and iterate upon their projects, you can wrap up the class, have them make sure their rubrics are filled out, and then you can circle debrief and hand out badges, and make sure you leave them with the parent reports. And finally, you can prep and practice in the STEM collab. Let us know how this went for you and what your students were able to do with this challenge. One more thing I want to show you quickly is that there is a debug challenge associated with this challenge here in the Scratch debugging exercises. And how this works is you come to this page, you'll see here there's a working version of this challenge. And that's good. Here, under that, you'll see a link to a bugged version of the challenge. And if we open this up and we try to play it, we see there are some things that are seriously wrong with it. So if your students finish up early, or you want to do this, as a do now for your next period or for your next class after this, you can use this debugging challenge to check your students' understanding, and just as another little extra challenge on top of this Scratch Basics number 3. Okay, so hope you enjoyed this webinar. I hope this was useful, and good luck delivering this challenge. Bye.